Hello and welcome to another video. Today we're going to be doing Pascal's Triangle 2, which if you haven't done Pascal's Triangle 1, it's basically the same thing, except instead of getting one single cell, we're getting a row now. So given an integer, row index, return the row indexed row of the triangle. In Pascal's Triangle, each number is the sum of the two numbers directly above it. And so basically the way Pascal's Triangle works is the left side is all ones and the right side is all ones. And then all the middle values are the sum of the two numbers above it. So like this 2 is the sum of 1 and 1, this 3 is the sum of 1 and 2, this 3 is 1 and 1. So we even have some more that we can fill in here. So here it'd be 3 and 3, so it'd be 6. And then here it'd be 3 and 1, so it'd be 4. And so on, right? So every row is one more integer, and it always looks like this. 1, and then, all of this stuff. So for row index 3, we'd want to return this row here. For row index 0, we'd want to return this. For row index 1, we'd want to return this. So the rows are 0 indexed, where you have, row 0, row 1, row 2, row 3, row 4. So there's a few ways to do this. One way I'll briefly mention is you can get a number by doing DP. So like, let's say you want this number. You would just write like this is row, whatever this row is, and the column would be however it is, and just do DP. And then you can get every single cell by doing the DP. And the base case of the DP is if you have column 0 or you have column whatever the length of the row is, right? So I think if this is row 0 or 1 or 2 or 3 or 4. So if you have column 0, then it's going to be all of these. So it'll just be 1. And then if your column equals your row, you will also have a 1, right? And so even for here, this is row 0, column 0. So that's kind of the base case, and then you can build it up that way. And then your recursive case would be you go up a row, and then it's going to be the two items, these two items. So for example, this is at column 2, so we would want, going up a row. So let's say this is row 4 and column 2. You would want row 3, column 2, and then row 3, column 3. Add those up. Actually, sorry, it would be row 3, column 1, and row 3, column 2, and so on, right? So that's pretty straightforward how to do that. So that's how you do DP, but instead of doing that, we're actually just going to build these up. So this is kind of like bottom-up DP, I guess you can think about it. Essentially, we're just going to build our rows one by one until we get to the row we want. So how is that going to look? Well, let me show you. So what we're going to do is we're going to have this first thing. And we need to build, like for this first example, we need to build 3 rows, right? We need to build, so this is row index 0, 1, 2, 3. So we need to build this row, which means we need to build 3 rows because we're going to build row by row. So for every row we're going to build, it's going to look like this. It's going to have a 1 at the start, a 1 at the end, and then the middle will be all the summations of the row above. Because as you can see, for all these rows, there's a 1 at the start, 1 at the end, right? So for this row above, this is row index 0, all the summations of the row above, meaning every 2 adjacent elements, we're going to add those up and return the value. So here there are no 2 adjacent elements, there's only 1. So actually our row that we built is just going to look like this. So it's going to be this. And as you can see, that is right for this one. Now let's build the next row. So we're going to have the 1 and then the 1, right? So 1 here, 1 here. What's in the middle? Well, we're going to go through every element here and add it to the element after it. So here there are only 2 elements, so there's only one thing to add, so we will have 2. And that is the third row. That's what it looks like. So now that we have this row, to make another row, once again, it's going to have a 1 at the start, 1 at the end, and then everything in the middle will be the things added, right? So 1 plus 2 is 3, and then 2 plus 1 is 3. 1, 3, 3, 1 is what we have. So we can actually build a couple more rows even for practice, because it's pretty straightforward. So to build the next row, once again, 1, 1, and then you do all the sums, right? So 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and we'll build one more. And as you can see, every row has one more element. So for this row, it would be 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, and 5. So you can see, like, you can keep doing this, right? And 1, 3, 3, 1 is actually the row we wanted, but this one is also this one, and this row would be down here. So we can just keep building these rows, and we only need to keep track of the previous row and the current row we built, right? So we start with this, and then when we build this, once we build it, we can just say, okay, let's just delete that and only keep track of this, right? you only need to keep track of the row that you built and the previous row, and that's it. So we're not going to keep track of like this whole triangle. We're just going to keep track of one row, and then we're going to build up and so on. And so this is pretty much like as easy of a bottom-up DP as it gets, kind of, I guess, if you want to think about it that way. So let's actually code it up. So we're going to have our initial case, right, where the row is just 1. And then basically we want to build a new row index times, right? So for this row index, like let's say we want to get row index 3, we want to build 3 new rows. So we can just say for I in range row index, our row can just be 1 plus, so we're actually going to do a list comprehension here. So we're going to list comprehension through our old row. So we're going to say row j plus row j plus 1, right? Whatever index we're on, let's add that and the one after, and this ensures that, and essentially we want to go through every index except for the last one, because like in our picture, you know, when you're doing these, like for a list, let's say you're on this index, then you add this plus this, you're on this index and you add this plus this index, but you don't want to be on this, you don't want to be in the last index because there's nothing to add. So we want to essentially go, this j needs to be every index in the old row except for the last one. And so that's going to be for j in range. So if you think about like what this needs to be, so I starts off at 0, right? So ideally, you want the last index to be the second to last element. So here, there is only one element, so you wouldn't want to do anything. So actually what you need to do is you need to say I here, because let's just go through it for a couple of these, I guess. So let's actually finish writing and then we'll kind of see how this works. So essentially what would happen here is it would start at index 0, right? And for index 0, range 0 is nothing, right? Because it starts at 0 and ends at 0, so that's nothing. So then what you want to do is you want to actually go through range 1, and then range 1 would give you only index 0, which is what you would want, right? Because the first thing you build up is like this, so range 1 would just only do this index, which is what you want, and then range 2 would have, you know, we'd have 3 items now, and then range 2 would be this one, and so on. So essentially, you can just try to, like, you know, when you're doing these things, you can also make it not like in one line, you can make it bigger, or you can just keep like trying to make sure your index is correct. But essentially, this is the index you want to make sure it all works. And then finally, so essentially what we're doing is we're just overriding our row, right? We're saying whatever our row is, let's override it with a 1, and then a list comprehension of that row where you add every element to the element after it, and then a 1 at the end. And we need to do that row index times. Then finally, we can return the row. And looks like we have an error. Syntax error. Okay. So I think we probably have an unmatched something, too many parens somewhere. I think it's this one. There we go. So essentially, we're just building this up and up until we have the right thing. And about this time and space complexity, this is actually as efficient as it gets. Apart from, there is like a math efficient solution, but this is as efficient as it gets. So also, if you think about it, doing this versus calculating every element is actually the same time complexity. We're just saving space because we're only building up one row here instead of multiple rows. But yeah, pretty much every solution is going to be like this, where it's going to be like n squared time, I think. Something like that, we'll go over it. And then there is like one combinatoric solution which gives you something right away. I think it's like a lot faster, but coming up with a combinatorics isn't like the best thing to do. So, but yeah, so this one's a pretty good one. And let's actually think about the space and time for this one. So for the time, if you think about it, we're essentially going down like to the row we need. So whatever this row index is, we're building and building and building. And how many rows do we need to build? Roughly row index, like, this isn't exactly n by n, but it's roughly that, right? So like to build row 4, we need to fill in 3 elements and so on. So it's roughly that. So this is basically n squared for time, because forever, like, it's not, like I said, it doesn't look like a square, but it's roughly a square. Okay. And for the space, it is actually O of row Yeah, so essentially we only have one row now, so how big is the row? Well, it's going to be roughly row index, right? So if we need row 3, it'll be roughly, it'll actually be like one more element than row index, but it'll be the same thing. So essentially, roughly O of n, where n is like the row you're on, because that's the biggest row we're going to build. So if this is like 3, then our row is going to have 4, and so on. So it's roughly that. And yeah, pretty easy bottom up TV problem for this one. Like I said, you could also do it with a normalization. You go through your row, you get each number with a visited dictionary, also works. Those are the main ways of doing it, other than the combinatorics. It's kind of hard to come up with. So hopefully you liked this video, and if you did like it, please like the video and please subscribe to the channel. And I'll see you in the next one. Thanks for watching.